Welcome to another digital microscope comparison video. This video will be a three-way showdown between these three different digital microscopes. Included in this comparison is the LM249 digital microscope from Linkmicro, which has been very popular with other tech influencers that I follow. I'll be comparing the Linkmicro microscope to two microscopes that all look strangely similar to one another. Are the microscopes all the same, or are there differences? Let's find out. I'll also be doing a giveaway for the Linkmicro microscope. See the description for details on how to enter. With all that out of the way, let's jump right into the comparisons. First up, we'll take a look at the Linkmicro LM249S-M Digital Microscope. Linkmicro was kind enough to send this microscope for free for me to review. They even agreed to send it after I said I would be tearing it down and comparing it against other digital microscopes with the same level of scrutiny as the previous digital microscope comparison video. One of the first things that I noticed is that the Linkmicro manual has a photograph of an Andonstar microscope. Inside the box is a component sheet along with instructions on how to assemble the microscope. The LM249 comes with a 10-inch monitor, whereas the LM246 comes with a 7-inch monitor instead. In both cases, the microscope is attached directly to the back of the monitor. On the back of the monitor is an HDMI mini connector for connecting to an external monitor, a USB micro for power or computer connection, and a slot for a micro SD card. One way to power up the microscope is to use this included cable. The cable has three buttons, one for power and one for increasing and decreasing the brightness of the attached LED lights depending on where you plug in this barrel jack. It also has a micro USB for connecting power to the microscope and a very long USB Type-A for connecting to the provided USB wall adapter. In order to assemble the microscope, the lens that's installed has to be removed. There are two thumb screws holding the lens in place. The lens can be replaced with any of the three lenses included in this microscope kit. After removing the lens, the microscope tube can be inserted into the holder and secured in place with the two thumb screws. As I just mentioned, there are three different lenses included with this microscope. In this video, I'll be evaluating all three of these lenses, but I'm going to start with the L lens because I think it will provide the lowest magnification image. After attaching the lens to the microscope with the two thumb screws and raising it to its highest position, we're ready to start looking at stuff with the microscope. I just so happen to have a silicon wafer nearby, so let's put it under the microscope and see what it looks like. My first impression of the microscope was that I really like the quality of the panel used. It provides a really nice, clean, crisp image. Before I get too far ahead with this microscope though, there's two others to unbox. Next up is the TOMLOV DM602 digital microscope. This microscope also comes with a very nice full-color manual. One thing I thought that was strange was this USB-C adapter sitting right on top. I was worried that it may have damaged the monitor, but everything looks fine. The monitor looks identical to the Linkmicro monitor, but the stand is a little bit different. This stand has teeth built into it to allow the microscope to climb up and down. Just like before, the lens comes off to be able to install the microscope onto the stand. It's just a personal preference, but I think I like this type of stand better. The last microscope is the Andonstar AD249S-M. The contents inside the Andonstar microscope box appear to be identical to the Linkmicro. The main difference between the two microscopes is the text on the front of the monitor. Other than that, on the surface, the three microscopes all appear to be essentially the same. I'll have to take apart each microscope to see if there are any differences inside. Before I accidentally break a microscope during a teardown, let's compare how they work to one another. Having them arranged side by side like this, it's very easy to see just how similar they are to one another. There are some subtle differences, but overall, they are identical. First things first, let's turn these microscopes on. If I pause the video right here, we can see the first difference. The TOMLOV has its own splash screen, where the other two have the same welcome screen. I wanted to check the power consumption from each microscope and see if there was a difference between them. The Linkmicro drew about 3.8 watts with just the LEDs and about 9.4 after booting. The power draw jumped about a watt when starting to record a video. At the lowest power setting for the TOMLOV, the LEDs drew about 0.6 watts and about 3.3 at max. After booting, it consumed about 9.4 and the same 1 watt increase when starting to record a video. All of the Andonstar's power numbers are essentially identical to the TOMLOV and the Linkmicro. At first glance, the microscopes appear to offer a wide range of resolutions for video recording. Similarly, the microscope offers a wide range of photo resolutions to choose from. There are lots of other settings like quality and sharpness that can be adjusted. Whether or not they do anything is something I'll also take a look at later in the video. In the secondary menu, there's an option for enabling Wi-Fi, and you can also check the firmware version. One thing that I thought was interesting was that I was actually able to control all 3 microscopes at the same time with a single remote. I also noticed that the TOMLOV software is slightly different. Next, I'll compare all of the accessories that came with each microscope, starting with the lenses. Each microscope comes with a set of 3 lenses. The D lens has the highest magnification out of all the lenses, but the shortest working distance. The maximum magnification for all the lenses is different depending on what model, according to the manuals included with each. For example, the D lens has a magnification range of either 1000 to 2000 or 1800 to 2040 times. The A lens and L lens both have a much larger working distance, but a reduced magnification overall. Later in the video, I'll determine what the actual optical magnification for each lens is and if it differs between them. Each microscope also comes with its own set of slides and slide holder for looking at slides under the microscope. The Linkmicro and Andonstar both have 5, but the TOMLOV comes with a set of 10 slides. The slide holders appear to be identical, other than the fact that the TOMLOV had the holders assembled and the others did not. The slide holders all use the same barrel jack as the main microscope to supply power to the LEDs underneath the slides. The microscopes all come with the same power adapter and cables. In addition to the crazy octopus cable, there's a USB for connecting to a PC, an HDMI to mini HDMI for connecting to an external monitor, and the same power brick. The microscope also comes with a remote control, and they all appear to be identical. That being said, the PCB inside is slightly different. I'm not sure what's meant by 7AAA, but a regular AAA battery worked just fine. Lastly, each microscope comes with its own SD card. The Linkmicro and Andonstar both have a 32GB SD card, and the TOMLOV comes with a 64GB card. I tested all 3 SD cards with H2 Test W, and they all passed. I'm still not sure why the TOMLOV came with this USB to USB-C adapter though. With all of that out of the way, it's time to look at what these microscopes can do. Let's start with the A lens. According to the documentation, the magnification is somewhere between 2 and 720 times. Although there is a note that this is based on the 3x digital zoom on a 28-inch monitor, so this is actually the apparent magnification, not the true magnification. Let's see how it stacks up to the optical microscope references. From end to end, this scale is 1 millimeter. Extrapolating this out, the total dimensions for the image are 1.7 by 1.275 millimeters. If I overlay the 50x reference image, you can see that the A lens produces a more zoomed in image. Using ratios, I can determine that the magnification of this image is approximately 73.5 times, or about 75x. I can confirm this by overlaying the 100x reference image. The maximum optical zoom of the A lens is right in between them. Here's what the minimum zoom of the A lens looks like. Using a ruler, this image appears to be 61 by 46 millimeters. If this image was 640 by 480p, it'd be really close to being 0.1 millimeter per pixel. Next, we'll compare the A lens on the TOMLOV digital microscope. After zooming in the microscope as far as it will go, it looks identical, and overlaying the other image from the Linkmicro confirms it. There is a difference on the minimum zoom though. Due to the differences in the stand, this image is only approximately 53 by 40 millimeters in size. Lastly, let's take a look at the A lens on the Andonstar microscope. If you had guessed that this would also be identical, then you're right. It's exactly the same as the first two microscopes. The minimum zoom does measure 64 by 48 millimeters, so I must have not had it all the way up on the Linkmicro microscope. Up next is what I'm looking forward to the most, the D lens, starting with the Linkmicro microscope. I was surprised by the level of zoom that this lens can achieve. Using the same logic from the A lens, let's determine the D lens's magnification. I counted this image to be approximately 0.74 millimeters wide, so using similar ratios to before, the magnification can be calculated as approximately 170 times. It fits in between the 100 and 200x reference images. Doing a similar calculation for the minimum zoom, I arrived at a total of 40 times magnification. These numbers are even a larger discrepancy compared to the numbers in the manuals. The ratios aren't even the same. Looking at the D lens on the TOMLOV, we can expect similar results. Apparently I did a slightly better job at focusing the image on the TOMLOV because this time it measures 0.71 millimeters. This of course increases the overall magnification of the D lens, but still puts us nowhere near what the manual states. I was more consistent on the Andonstar as well, and the images between the Andonstar and TOMLOV look almost identical. In general, at this high of a zoom level, these microscopes are very finicky trying to get the images focused just right. Lastly, let's take a look at the L lens. I'll switch things up and I'll start with the minimum zoom for the L lens instead. The L lens has a much smaller range of magnifications. I calculated the minimum optical magnification of the L lens as approximately 8.5x and the maximum magnification at approximately 30x. Taking a look at the TOMLOV with the L lens, I can highlight the main difference between the TOMLOV and the two other microscopes. As I mentioned before, due to the stand differences, the TOMLOV can't get as high as the other two microscopes. Another difference is that the TOMLOV has a fixed distance of about 7 millimeters from the stand to where the specimen needs to be, compared to the adjustable distance of 10 to 17 millimeters for the Linkmicro and Andonstar stands. The close distance on the TOMLOV does make it hard to utilize the included slide holder. On all models, the stand can pivot if you loosen a bolt, but it's not easy to do by hand and you need a tool to do it. The result of the stand differences is that the TOMLOV has a slightly cropped minimum zoom, but the maximum zoom is identical to the other microscopes. Speaking of other microscopes, here's the Andonstar with the L lens. At the max height, I measured approximately 21 millimeters of working room. The images that the L lens produced on the Andonstar microscope are identical to the images from the Linkmicro with the L lens. Here's a table that I put together with all of the results. From this testing, I was able to confirm that all of the lenses have the same magnification, even though they are advertised as being different. Of course, one thing that I had to do with these digital microscopes was use them to look at a silicon chip. Unfortunately, it's hard to see the chip due to the very short working distance and not being able to get enough light under the microscope. To try and solve this, I attempted to shine a flashlight under the microscope, and had some pretty decent results. With the light angled in the right direction, you can see a lot more detail on the chips. Here's what a 1080p 60 frames per second video of that looks like. It's definitely not perfect, but a lot more detail could be seen with better lighting. The intended use of the D lens, however, is to be used in conjunction with the microscope slide holder, which can be used to illuminate translucent objects, like this pine stem sample. Once again, the images between all three microscopes are essentially identical. Just the sample is different. A drawback of the D lens, however, is that the microscopes are susceptible to any small vibrations. It does seem like the TOMLOV microscope appears to be slightly more resistant to vibrations, which I think was probably due to the stand difference. I'll take some video and we can see what the vibrations look like. Unsurprisingly, the vibrations are captured on the videos and result in a very blurry and shaky image, even when recording at 60 frames per second. The TOMLOV with the different stand does appear to be slightly less shaky, but it's still not great. As the manual states, you must have lots of patience if you intend to use these lenses. We finally reached my favorite part of the video, the teardowns, and I'll start with the Linkmicro. There appears to be only 4 screws holding the microscope together. I did notice that the microscopes all have a sticker covering up an additional headphone port. I wonder what this could be used for. After removing the 4 screws, the 2 halves can be carefully separated and the flex cables removed. This allows the monitor to be completely separated from the rest of the microscope. I do appreciate how sturdily this monitor appears to be attached. On the other half of the microscope, there's actually not too much to look at. There's a small blue circuit board in the middle and a black one on the side for the Wi-Fi antenna. The circuit board can be removed with another 4 screws, and then the ribbon cable connecting the circuit board to the microscope below can be separated. There's not much to see on the circuit board because both sides are covered with these cages. That being said, they can be easily removed with just a little bit of prying. After bending back all the tabs around the edges, the shields can be removed. There's a lot of interesting circuitry underneath to look at. Let's use one of the other microscopes to get a closer look. On this side of the PCB, there are 2 interesting parts that caught my eye. The first part is this Macronic 64 megabit SPI flash. If I had to guess, this is where the firmware is stored that the microscope runs. On the other corner of the PCB is a Wi-Fi module powered by the RTL 8189 chipset from Realtek. Everything else on this side appears to be glue logic or power supplies, so we'll move on to the other side. Removing the lid reveals some very interesting chips. The big square chip is the CPU, the NT96663 from Novatek. It was actually surprisingly hard to find a datasheet on this CPU. The information that I did find says that it's a 32-bit CPU running at 420 MHz. I also came across this website that had a very nice diagram of the CPU. This block diagram shows all the different features that the CPU has, along with some of the internal processing blocks. This CPU supports up to 4 GB of DDR3 memory, and that's exactly what this chip is. Nearby the CPU is the TechPoint TP9950. I wasn't able to find a datasheet for this part, but I did find these 2 snippets. Potentially this is used to interface with the LCD panel, but the CPU does have a native LCD interface, so it's hard to say. Looking at these boards under the microscope made me think that these would be really useful for soldering. The images are really clear and there's no lag or delay on the monitor. The lights on these microscopes are all very bright and they illuminate the PCB very well. Moving on, here's the TOMLOV microscope taken apart. At first glance, everything inside appears to be identical to the Linkmicro microscope. Of course, the only way to confirm is to take the circuit board out and see what chips are on it. The CPU is the same, but this only uses 2 GB of DDR3L. Everything else appears to be the same to the Linkmicro circuit board, even the Realtek chip, which I thought was interesting since there didn't appear to be an option to enable Wi-Fi on the TOMLOV. Next, I'll take apart the Andonstar digital microscope. Once again, everything inside the Andonstar appears to be identical to the other 2 microscopes. Taking a look at the circuit board confirms that this is identical to the TOMLOV. It also uses the 2 GB chip instead of the 4 GB DDR chip. One thing that I did notice is that every piece in the microscope has a part number. Most of these numbers appear to start with AD followed by a 3-digit number. I put all of the part numbers into a table and here's what it looks like. The main differences between the microscopes are the firmware, the RAM, and the monitor. Other than that, the microscopes are very similar. The microscopes are so similar in fact that you can even do something this diabolical. I connected the TOMLOV mainboard to the Andonstar Monitor and everything worked fine. Up next is to tear down the microscope tube and look at the sensor. The entire image sensor board can be moved up and down in the camera tube to adjust the focus. To get a closer look inside the microscope, this last screw needs to be removed. After removing this screw, the tube can be separated, revealing the gooey inside. The tube is loaded up with grease so that adjusting the focus is as smooth as it can be. That being said, there's still a severe amount of backlash as you change directions. I was worried though that if I took the entire microscope tube apart, I wouldn't be able to get it back together. I was, however, able to get it under the microscope so we could get a closer look at it. Unfortunately, I had to hold the sensor in place while I took this video, so it's not the greatest. I was able to look around the entire image sensor, and I was trying to find a model number or the maker of this chip. After looking all around the chip, I wasn't able to determine what this image sensor is. But I do think I was able to finally figure it out, thanks to a website that I stumbled across. I also attempted to look at the individual pixels on this sensor, but it's not the greatest. There's a lot of interference from the protective layer that's on top of this chip, so it's really hard to make out the individual pixels. Zooming back out, here's what the entire sensor looks like from each camera. Unsurprisingly, each camera appears to use the exact same image sensor. While I was searching for more information on the CPU, I stumbled across this dashcam website. This particular dashcam happened to pair the same CPU with the OV4689 image sensor. Searching for the OV4689 led me to this page with this image, which looks identical to the image sensor that is on the microscope. This is interesting because the OV4689 is only a 4 megapixel sensor. This, of course, is in contrast to the maximum resolution that the microscope can allegedly take photographs at of 24 megapixels. The product brief listed on the OmniVision website also has a lot of other great information about the sensor, including a really nice block diagram. To confirm this was the actual sensor used in the microscope, I looked at the other offerings from OmniVision. None of the other image sensors that I looked at were a match besides the OV4688 and the OV4686. These image sensors are all 4 megapixels and they all appeared to look identical. While we're on the topic of resolution, I thought it would be good to compare all of the photos that can be taken with the microscopes. I took a picture at each resolution and loaded them all up into Inkscape. The images do appear to have the correct amount of pixels for each megapixel size. However, since we know that the image sensor is only 4 megapixels, anything larger than 4 megapixels has to have been interpolated. As I zoomed into each high megapixel image, they all appeared to look identical to one another. I also thought it was odd that there is no 4 megapixel setting on this camera. Only 3 megapixels or 5 megapixels. Everything under 5 megapixels does look different when I zoom in. Lastly, I compared the different image quality settings on the microscope. These images were all taken at 5 megapixels with different settings. Can you tell a difference? I can add the image sensor to the comparison table, but since I don't know exactly which one it is, I left the last digit as an X. Earlier, I pointed out how each circuit board starts with the letters AD followed by a 3-digit number. To me, these all look like different Andonstar part numbers for different microscopes. For example, the AD400 could refer to the AD407 or AD409. And of course, the AD246S is self-explanatory. Seeing all of this makes me think that the TOMLOV and Linkmicro are both clones of the Andonstar microscope, but in order to confirm this, I have to do some research. I first head over to the Andonstar website to check it out. There are quite a few different models to choose from. I thought it would be interesting to see what happens if I plugged the Andonstar website into the Wayback Machine. Surprisingly or not, there's quite a few caches all the way back in 2016. Clicking on the earliest link brings us to this website. It's still the Andonstar website, and it looks like they were selling digital microscopes as early as 2016. According to the About Us section, they're a relatively new company that has been producing USB microscopes for the past 10 years. This is in contrast to what their website currently says, that they were established in 2013, making them perpetually 10 years old. They do at least provide a timeline on their website, which basically checks out with the cached version of their old website. Next, let's see how TOMLOV holds up. On their front page is the DM602 Pro, which is a slightly upgraded version of the microscope that I have. And when I say slightly, I mean a ring light and the same stand as the Linkmicro and Andonstar microscope. All of the other features appear to be identical. According to the About Us section on the website, TOMLOV is a diversified brand that integrates the R&D, production, and sales of digital microscopes. They don't go so far as to state how long they've been making microscopes, but we can find that out pretty easily. Once again, using the Wayback Machine, we can see that the first hit for the TOMLOV website is back in 2018. By loading up the oldest cached website, we can see that TOMLOV was selling baby monitors back in 2018. There's some interesting text at the bottom of the website, which leads me to believe that TOMLOV is owned by Blue Sky C. Blue Sky C currently sells various dash cams, which, as we saw before, are essentially the same components as these digital microscopes. If I load up a later cached image from 2020 of the TOMLOV website, there are still no digital microscopes listed. There are quite a few new interesting products available, like this restaurant pager system. The About Us section at the bottom of the page has also been updated to say TOMLOV is a brand that sells security camera and its peripheral products. There's still no mention of digital microscopes in 2020. Jumping all the way to October of 2022, the TOMLOV website now features exclusively digital microscopes. The About Us section has once again been updated and is very similar to what is currently on their website. My favorite line is the company has an engineering and technical team engaged in the research of microscopic instrument application technology. Based on everything that I've seen so far, it really looks like the TOMLOV is a copy of the Andonstar microscope. That just leaves the Linkmicro. Unfortunately, there doesn't appear to be an official Linkmicro website. After scrolling past various reviews of the Linkmicro microscopes, I finally found the Linkmicro link tree. Unfortunately, it doesn't include any additional information about who Linkmicro is as a company. I think it's pretty obvious at this point that the Linkmicro is also a clone of the Andonstar. Even though the TOMLOV and Linkmicro both appear to be copies of the Andonstar, I'm still not convinced that the Andonstar isn't itself a clone of something else. That being said, if you think that this microscope would be the right fit for you, I would recommend going with whatever one you can find for the cheapest price, since they all appear to be the same thing on the inside. I would also suggest considering going with the 7-inch version, since the only real difference between the microscopes is the size of the display. Based on the current offerings I found on Amazon, the Linkmicro and TOMLOV both are tied for the cheapest price for the 7-inch microscope. I've included Amazon affiliate links for all the microscopes listed here in the description below. I would recommend checking all the links before making a purchase, as the prices may fluctuate. If you're looking for a microscope to observe silicon chips at the microscopic level, I would unfortunately not recommend these microscopes. But for other uses like soldering or just general purpose microscopic work, they're honestly not a bad choice. I would also like to say again, thanks to Linkmicro for sending out this microscope for me to review. As I stated at the beginning of this video, if you'd like to win this microscope, you can enter the giveaway by following the instructions in the description below. If you made it this far, thanks for watching the video. I have a bunch of other videos in the pipeline that I can't wait to finish editing. If you want to see what I'm working on in between videos, feel free to follow me on any of my social media accounts. If you're looking for other ways to support the channel, I would recommend checking out what I have for sale on my online store. And if you want to chat with me directly, the easiest way to do it is by joining the Chip Chat Discord. Thanks again, and I'll see you in the next video.